In this lesson, we're going to look at histograms. Histograms are sort of posh bar charts. If you could actually put down the heading histograms and underneath in brackets put posh bar charts, that will give you a reminder later on when we come back to this what histograms are. Now, because I'm not here today, I'm not going to give you all the reasons for why all of this works. I'm going to tell you a couple of key things and then get you doing some questions. So, histograms, okay, we've said they're posh bar charts. An example of a histogram is this diagram here, okay. The main difference between a bar chart and a histogram is in a histogram, the bars, now here's one bar, here's another bar, they're not all equal width. And it's not the height that's important, it's the area that's important. And on the left-hand side, you don't label it frequency, but you always label it frequency density. So we're just going to make a few notes about that before we go any further. So you should have written down histograms, posh bar charts. Can you write these things down underneath, please? Okay. First of all, sort of point number one, can you write down its area, not height. That's important. It's area, not height. That's important. So if we can write that down. Number two, if we just do a sketch of a histogram, this side here is always labelled frequency density. So if you can just do this sketch and just label that frequency density. And the third point we will have is the bars are usually different widths. The bars are usually different widths. If your teacher wants to pause that to give you a chance to write those 3 points down, they can do. Okay, in working out the histogram and drawing it, you've got to do a bit of work first of all. Now, in the big orange textbooks, that's these books, the 7 to 12 orange textbooks, can we find page 36 and question 3? Page 36 and question 3, it's this table, and I've written this table out here. I would like each of you to copy this table down. Bear in mind, in a minute, I've got to put on 2 extra columns. So can you give yourself room for those 2 extra columns? But I'm just going to zoom in so you can see that bit and then copy that bit down. As a teacher can just pause that there perhaps. Okay, so you've got that copied down. Every time you do a histogram, you've got to have a column for the width. Now the width is how far it is from here to here. So how far is it from 0 to 0.5? It's 0.5 wide. We put that in. How far is it from 0.5 to 1? That's 0.5 wide. So we put that in. From 1 to 3, it's 2 wide. From 3 to 4, it's 1 wide. And from 4 to 5, it's 1. So we put those widths in first. The next column we put on is the height. We need to know the height of each bar. Now, if you can go back somewhere where you're not writing this, maybe in your books, or if you want to write it underneath, you can. But there's another key thing here we want to write down. So we've got some key things already. What we're going to put down here, and the most important thing, is the height is equal to the frequency divided by the width. Height is equal to frequency divided by width. That is really, really important. You need to sort of highlight that in your books somehow. And the other thing I want to write down is area shows frequency. Now we wrote something similar to that down earlier. The area shows frequency. And if we can highlight that one as well. So those two need to be copied down. So over here, back to our table. We've got our table. We've worked out the width. We've got height over here. And we said a minute ago height equals frequency divided by width. And I'll just write that in there, the h equals f divided by w, if you can do that as well. Now what we need to do here is work out some sums, because I've got to work out on the first line, this line here, the height is the frequency number divided by the width number. So I've got to do 8 divided by 0.5. Now 0.5 is the same as a half. 8 divided by a half. Now if somebody just shouted out 4, they got it wrong. They've made the classic mistake. 8 divided by a half means how many times will a half go into 8? Well, a half goes into 1 twice. A half goes into 8 16 times. So 8 divided by 0.5 is 16. Because we can get a bigger answer than our starting number because the number we're dividing by is smaller than 1. On the next row, I've got to do 10 divided by 0.5. That's the same as 10 divided by a half. That's how many halves are there to make up 10. And the answer to that is 20. Now, if you get some of these and you can't do them in your head, you can do them on a calculator. But this one should be dead easy. 15 divided by 2, that's 7.5. 12 divided by 1 is 12. And 3 divided by 1 is 3. So at this point, we've finished our table. If you can make sure that's all copied down. And the next thing we need to do is to draw the histogram. Now I'm just going to do a very simple sketch first of all. Don't copy this down. Up here, I will have the frequency density, which is measured in the same thing as the height. So just looking at this, I need to go up to 20. Start at 0 and go up to 20. Along the bottom, I'm going to have the waiting times. I need to go from 0 to 5. So you just need to think about that and work that out before you go any further. Now I'm going to use graph paper. There's graph paper available at the front. And in a minute, when I finish doing the talking, you'll need to do this for yourself. So I need to go up to 20 and across to 5. So if I use some graph paper, if I do here a 10 centimetre line, I can go 0, 4, 8, 12, 16, 20, and that can be my frequency density. And I said along the bottom, I've got to go along to 5. I can do another 10 centimetre line along here, and I can go 1, 2, 3, 4, 5, and that is my waiting time. So I'll zoom in on that. Both of these lines were 10 centimetre lines, and I've gone up there in 4s and along here in 1s. Maybe a good idea now if somebody actually gives out the graph paper, let your teacher organise that please, and we can get that drawn. So a quick recap, 10 centimetres each direction, and now we need to use this and our table together. So here's our table, and here's our axes. Now the first thing we've got to do, the first row, the bar from 0 to 0.5 has a height of 16. So 0 to 0.5, a height of 16, will give us that bar there. Here's 0.5 and a height of 16. The next bar from 0.5 to 1 has a height of 20. So we can draw that bar in. And so far it looks pretty much like a bar chart. But the next one is a different width. 1 to 3 has a height of 7.5. 1 to 3, a height of 7.5. There's 6 halfway between 4 and 8. So there's 7. So there's 7.5. And I'm going along from there till I get to 3. And then I'm going down. So a key thing to look at the moment is, although in the table this row had the biggest frequency of the lot, it's bigger than 10, it's bigger than 8, it's not the highest bit. It's actually got the biggest area, but it hasn't got the biggest height. So the next one we have to do, from 3 to 4, we've got a height of 12. So from 3 to 4, I need a height of 12, and I can draw that one in. And the final one I've got, from 4 to 5, a height of 3. So what I've got now is a histogram, where the area of each block represents the frequency, It says frequency density at the time because it's not frequency. This bar here going up to 16 does not mean there were 16 people. If you want to work out the frequency from the diagram, you need to find the area of each bar, and we'll look at that separately.